So now we will discuss example from the previous case which we have discussed. So now we will discuss an example. So we have a problem that if Hn is equal to half n un and Xn is equal to a exponential j pi by 2, right, where this is multiplied with n and n is varying from minus infinity to n. Now this is our question. So we want to find out the solution of this particular problem. So we know h omega is equal to summation n equals to minus infinity to infinity hn exponential minus j omega n. Right? So if we'll substitute the values, it will be summation n equals to minus infinity to infinity hn is half to the power n un and this is exponential minus j n, that will be equal to n equals to 0 to infinity half to the power n exponential minus j n. Then we can write it like this: n equals to 0 to infinity, that is exponential minus j omega by 2 to the power n. Now this particular equation is nothing but a geometric series where this particular term is a, then it will be equal to 1 infinite, it is infinite geometric series, it is 1 upon 1 minus a, right? So that is equal to 1 over 1 minus exponential minus j omega by, right? Now we know xn is equal to a exponential j pi by 2 n, and comparing with x dash n, which we have already knew, a exponential j omega n, we will get that is j omega n equals to j pi by 2 and cancelled out, j cancelled out, then it is omega is equal to pi by 2, right? Now for this case we can find out h omega for omega is equal to pi by 2, because our xn is defined for pi by 2, so then it will be equal to 1 over 1 minus 1 by 2 exponential minus j pi by 2, right? So we know from this case exponential minus of j omega is equal to cos omega minus of j sin omega, right? So if we put our exponential minus j omega where omega is equal to pi by 2, it will be cos of pi by 2 minus j sin pi by 2. So cos pi by 2 goes to 0 and sin pi by 2 goes to 1. So then can be written as, sorry, I'll just do use black pen again. So it is 1 over 1 minus 1 by 2 minus of j, right? So this equals 1 over 1 plus j. Now we want to find out the relation in the polar term. Then it is 1 minus j 1 by 2 over 1 plus 1 by 4. Right? So actually what we have done is we have multiplied with 1 minus j 1 by 2 and 1 minus j 1 by 2. Right? So it is a square minus b square. So it is j minus 1. Then it comes with 1 plus 1 by 4. Okay. So this particular term can be written as 4 by 5 minus j 2 by, and if we want to find out in polar terms, that will be mod of h omega equals to that is, say it is 16 plus 4 is 25. So it is 4 by 5, that is 2 under root 5. Now angle theta is tan inverse imaginary quantity or real part. So tan of inverse imaginary part is minus 2 by 5, real part is 4 by 5, equal to minus tan inverse 2 by 4, and that is equal to minus of tan inverse by 2, which is equal to minus of 26.6 degrees. Then h omega is equal to mod of h omega exponential theta, that is mod of h omega is equal to 2 under root 5 exponential minus j 26.6 degrees. Right? And we know for eigenfunction exponential j omega n yn is equal to a h omega exponential j omega n, then yn at omega is equal to pi by 2 is equal to a 2 under root 5 exponential minus j 26.6 degree, and exponential j omega n is equals to j pi by 2. Right? So this we have find out the value of yn at omega is equal to pi by 2. Okay. Thank you for this particular part. We will discuss further of this in next lectures. Thank you.